Hey everyone, thanks for tuning in. Today we'll be looking at the ASTC rule. What I'll be talking through is just an introduction of the four quadrants, how the ASTC rule applies to that, and how we actually come up with the ASTC rule. Later in the lesson, I'll be taking a look at some actual examples in how to apply the ASTC rule using the reference angle, or the general angle as it's sometimes called. So let's begin. First of all, we start off with, well, what are the four quadrants, okay? So typically, we have our axes, namely the x-axis and the y-axis, and we split it up into four quadrants, okay? So the first quadrant over here, second, third, and fourth quadrant, okay? So we just basically need to know which quadrant is the first one, which quadrant is the second, the third, and the fourth, okay? Once we're familiar with this, then we can get into the applications of the ASTC rule. So what we look at is this unit circle here, okay? And we define this circle by this rule here, x squared plus y squared equals 1, where the x-axis is the horizontal axis and the y-axis is the vertical. And what we've got is we've got this circle of radius 1, okay, represented by this. And what I've done is I've just identified basically just a point, okay? Just a point. This point can be anywhere amongst the circle, but just for ease, I've identified it here in the first quadrant. And this point P has coordinates x and y, all right? And what we're going to do is we're going to represent this point in terms of an angle. And what we're going to say is that it has an angle theta, okay, where theta is basically this angle here. All right, so it's the angle it makes from the positive direction of the x-axis to the and we read it counterclockwise. So the way we read the angle is we start here and we read it that way, okay? So what we've got here is the angle theta to represent the angle in which this point is directed out from the x-axis. And what I'm going to do is construct a right angled triangle, okay, where this is the right angle there, okay. So once I've constructed this right angle, I think it's important to notice that the x coordinate of this point is going to come from here. Okay, so this distance there is just going to be the x coordinate of that point. And this vertical distance here happens to be the y coordinate of that point. Okay, and using basic trigonometry, we should observe a few things. First of all, we need to observe, by just using basic SOHCAHTOA, we see that cos theta, remember, cos theta is equal to opposite over adjacent over hypotenuse. Now, the adjacent side here is x, okay? So it's adjacent x over the hypotenuse of the triangle, which is this here. Now, the question is, well, what is this length here? And the answer is 1. Reason being that this length here is the radius of the circle, which is going to be constant, and it's going to be 1, okay? So it's cos theta is equal to x over 1, which is just equal to x, okay? So what we observe is that the x coordinate of this point is just equal to the cosine of whatever angle it makes when we extend out from the x-axis. By a similar reasoning, looking at the definition of sine theta, we get sine theta is equal to opposite over hypotenuse, which is y over 1, because that's the opposite side over 1. And that's just equal to y. So yet again, the y coordinate of any point on this circle is equal to the sine of whatever angle it makes from the x-axis. And finally, we look at tan theta is equal to opposite over adjacent, which is equal to y over x, okay? And once we've got these, we can apply them, okay? So what we look at is, what we're going to notice is that in the first quadrant, all right, the x-coordinate is going to be positive, and the y-coordinate is also going to be positive. This implies that the cosine of whatever that angle is, if it falls in the first quadrant, is going to be positive because the x-coordinate is positive, and by a similar argument, sine theta is going to be positive because the y-coordinate is positive. That is when theta is in the first quadrant. Okay, so if we're looking here, what we have is we start at 0 degrees and we go up to 90 degrees, then around to 180 to 270, back up to 0 or 360 degrees. Okay, so in the first quadrant, it's between 0 and 90 degrees. So that implies if we have an angle, namely a theta, which is between 0 and 90 degrees, it implies that it, first of all, lies in the first quadrant. And that means that cos theta, sine theta are both positive. Okay, cos theta and sine theta are both positive. And tan theta is also positive. Reason being because it's y over x, and we just found that the y-coordinate is positive and the x-coordinate is also positive, so a positive over a positive makes a positive. And that is why we define in the first quadrant all the trig functions, sine, cos, and tan, are going to be positive. Okay? By a similar argument, imagine that theta falls in the second quadrant. That means that it's going to be in this region here, namely between 90 degrees to 180 degrees. Okay? What we're going to say, if it falls in this quadrant, okay, what we should notice is that the x-coordinate is negative and the y-coordinate is going to be positive. This implies if the x-coordinate is negative, cos theta is negative because cos theta is equal to the x-coordinate, and sine theta is going to be positive because the y-coordinate is positive. And tan theta is going to be negative as well because it's y over x, and y is positive and x is negative. And a positive over a negative results in a negative. This implies, so cos is negative, sine's positive, and tan's negative. So sine is the only one that's positive, and that's why we get S in that second quadrant. Okay? For the third quadrant, we're dealing with angles from 180 to 270. Alright? And looking again, what we see is that in the third quadrant, which is somewhere here, the x-coordinate is negative and the y-coordinate is negative. So that means cos is negative, sine is negative, and tan is going to be positive because it's a negative over a negative, which is a positive. That implies that tan is the only positive one in the third quadrant. And finally, if we're looking at the fourth quadrant over here, so any angles between 270 to 360, we have the x-coordinate will be positive and the y-coordinate will be negative. Okay, this implies that cos will be positive because the x is positive, sine is negative because the y-coordinate is negative, and tan theta will be negative because it will be a negative over a positive. Okay, so cos theta is the only one which is positive in the fourth quadrant, and it's represented by the C. Hence, how we get the ASTC rule. So next, once we've identified, or at least once we know how to use the ASTC rule, it's a matter, or at least understand the concept of it, it's a matter of now, how do we actually apply this knowledge? Okay, and we look at something known as the reference angle. Okay, and what we say is that given any angle in any quadrant, we can always relate it back to an acute angle in the first quadrant, namely this one here. And I'm going to call this theta. Okay? And hopefully what we can see is by vertically opposite angles, all right, this angle here is also going to be theta. Okay? And I'm just going to say that this angle here is also equal to theta. Okay, so this angle here. And by vertically opposite angles with this over here, the angle over here is also equal to theta. So what was the point of this? And the basic premise of it is, well, really, you're just relating an acute angle to all the four quadrants. Okay, obviously any angle in the first quadrant is going to be acute anyway, by definition. However, for the other quadrants, what we can see is we can relate it with an acute angle. And so the question is, how do we define each of these angles in terms of this acute angle theta? Well, as we saw previously, the first quadrant is just going to be defined as theta. Okay. The second quadrant is going to be defined as 180 degrees minus theta. And the reason why is because, remember, we're reading the angles from the positive direction of the x-axis and reading it counterclockwise. Okay, so in that direction there. So what we're going to say is that this angle here, whatever this line is going to be 180 degrees. So to go all the way to the other end of the x-axis, and we're subtracting theta, because when we go into negative angles, we go, instead of counterclockwise, we go clockwise. So it's 180 degrees minus theta, and that gets us here. By a similar argument, we can define this one over here by 180 degrees plus that extra theta. Okay, so this is 180 plus theta. And this one over here in the fourth quadrant is going to be defined as 360 degrees, so go all around the circle, minus theta. So it's going to be 360 degrees minus theta. Okay? So this is how we define all the angles in any quadrant. So we can define any angle in any quadrant, and we can relate this to a reference angle, namely some sort of acute angle. Alright? So now I'll take you through just 3 examples of how to actually use this combined with the ASTC rule. Okay, so these are common exam questions, generally about 1 or 2 marks. So here, find the exact value of tan 300 degrees. Your first job is identifying where 300 degrees is going to lie in terms of the axes. Alright? And basically, what we have going on is we're going to start at 0 degrees, which is from here, and we read counterclockwise. So we go up, and 300 degrees lies between 270 and 360 degrees, meaning that it's in the fourth quadrant. Okay, so it's in the fourth quadrant here, right? Where this angle here is 300 degrees. Okay. So the question is, how do we relate it to the reference angle? And what you can hopefully piece together is that this here is going to be 60 degrees to complete the circle. And really what we say is that tan 300 degrees, well, we got to identify that it's in the fourth quadrant. And how do we identify angles in the fourth quadrant? It's going to be by 360 minus theta. Okay, so all I'm doing is just rewriting what 300 degrees is equal to in terms of that that way of expressing it in terms of an acute angle. So it's 360 degrees minus 60 degrees. Okay, that's literally what that's another way of writing 300 degrees. 360 minus 60 gives me 300. So now I can write this in terms of that acute angle, which is going to be tan 60 degrees. Okay, so it's equal to tan 60 degrees. Because once you get it in this form, you can relate it back to the acute angle. Now I am missing one thing, and it's a negative out the front here. Now why is it negative? Well, coming back to ASTC rule, we're lying in the fourth quadrant where only cos is positive. And what we've got here is a function in terms of tan. Okay, and in the fourth quadrant, so because we had 300 degrees, in the fourth quadrant tan is negative, hence negative tan 60. And by the exact values, we know tan 60 is root 3, so negative tan 60 is negative root 3. Okay. Now let's look at another example. Okay. find the exact value of sine negative 210. Okay, so where on the axis does negative 210 degrees lie? Okay, and remember we read the positive angles going counterclockwise. So negative angles we read in the opposite direction, so going clockwise. So we're going 210 degrees clockwise. So we go around, remember this is negative 90 degrees, and then negative 180, and so then this would be negative 270. And negative 210 obviously lies between negative 180 and negative 270. So it's lying somewhere here. So I'm just going to roughly say that's what it is. Okay. And this whole thing here is negative 210 degrees. Okay. So where do we go from here? Well, first of all, I think it's useful to identify that sine of negative 210 degrees is equal to sine of negative 210 degrees plus 360 degrees. Now, the reason why is because the angle representing negative 210 degrees is this line here, okay? And essentially, if we're going around another 360 degrees, we'll just come back to the starting position, okay? So what I'm doing here is just rewriting this angle just to make it nicer, so to turn it into a positive angle. So this ends up getting you 150 degrees, okay? That then implies that this angle over here, because this is between 0 and 360 now, it then implies that this angle over here is going to be 150 degrees. Okay? And now once we've got it in this point, to this point, the rest of it should be pretty simple. First of all, what quadrant are we in? And we've identified that we're in the second quadrant. How do we define angles in the second quadrant? Remember, it's going to be 180 minus theta. So I'm going to re-express 150 as sine 180 minus a theta. And now what's this theta going to be equal to? And it's going to be equal to 30. Because 180 minus 30 gives me 150. And now I re-express it in terms of my acute angle. Alright, and remember we need to consider if this is going to be positive or negative. And because we lie in the second quadrant, where sine is positive, then this is just going to remain positive. And what's sine 30 equal to? Well, it's equal to a half. That implies that sine negative 210 is equal to 1/2. Okay. The third and final example that we'll look at is this one over here. So cos 570, same thing. All right, we're going around 360 degrees, and how much more do we need to go around? Okay, so we go around 360 degrees, add another 90, and we get to 450, and add another 90 after that, and we get to 540 degrees. And another 90 after that is going to be 630. So what we're going to have is 570 lies within this quadrant, and the question is, well, what is it exactly? Like in terms of an angle between 0 and 360. Because at the moment, what we're doing is we're going around once, and we have to go around again into that quadrant, into this second quadrant. Into this third quadrant. So, like the previous example, where I added 360 to get this angle between 0 to 360, I'm going to do something with 360 degrees, but instead of adding it, because this is too big, I'm going to subtract it. So I will say that cos 570 is equal to cos 570 minus 360. Okay, and that will get me to cos of 210 degrees. So once I'm at 210 degrees, and I've identified that I'm in the third quadrant, that implies So how do we define angles in the third quadrant? It's going to be 180 plus theta. So 210 degrees is equal to 180 degrees plus how many? And that's 30 degrees. And I relate this in terms of my acute angle, which is the 30 degrees. And then the last thing I consider is whether it's going to be positive or negative. So remember, we lie in the third quadrant, which implies that it's going to be negative, because in the third quadrant, tan is only positive, so cos is going to be negative. And so it's negative cos 30, and by the exact values, cos 30 is root 3 on 2. So negative cos 30 is negative root 3 on 2. I hope this lesson made sense. If you're having any trouble with it, maybe revisit some of the examples that I looked at. Hopefully I've progressed through them in order of difficulty. And yeah, I wish you all the best with this sort of work, and I'll leave you with that. Thank you.